I I guess I'm audible. Let me know. Let me quickly set up my whiteboard. Up. In. Hi everyone, and welcome to Dreams. Today will be again like every other day. We'll be solving two problems. Now the problems we'll solve today are kind of important problem when we talk about interview point. So that's there. But other than that, also we have some problems for homework as well. So I would recommend you to complete as well because those problems are also pretty important when it right. So yeah, without wasting time, let's actually start with the first problem. So the first problem is you have to find the transition point. Now it's a very straightforward question. So you are given a sorted array consisting of zeros and ones. Find the transition point. Transition point means when it is converting from 0 to 1. So basically what you have to find is the first occurrence of 1 in right. So you have zeros and ones. You have to find the first occurrence of 1. That is the transition. 0 it is transitioning to 1. Right. So here in this case all are 0, so you are returning -1. So you have to find transition point. The complexity expected is order of log n and order of 1 space complete. Now I'm pretty sure that you already have realized what you have to do, right? It's very obvious question, like it's pretty straightforward that you are given zeros and 1 and you have to find the first occurrence of 1. So whenever you get such question, whenever you're given a sorted array and you have to search for something, it's definitely binary search, right? What you have to use is binary search. But I want to teach you here like how do we solve such problems. Like this problem that we have, right, this is the base of multiple problems that we can have. So I want to actually take that journey that hey, if we are able to solve this problem, then we can solve 10 other problems, right? Why do I mean this, right? So this is the question. Let's actually look into some unrelated question. Maybe we'll discuss such questions later on, but yeah, there might be questions like let's say you are given something like you are given uh, okay, let's talk about a problem which is from top coder, right? The problem is called fair workload. So let's actually talk about this problem and see how we can reduce this exact problem into something similar like this, right? So fair workload tells that we have some workers, right? We have some workers. Let's say there are n workers and there are m cabinets, right? There are n workers and m cabinets. Now the cabinets contains some files, right? So each cabinet contains ai files which is given by the array a. What you have to do is you have to partition the work into the workers, into a subset of the workers. It is not needed that you have to use all the n workers. You have to partition the work into some workers such that the maximum number of pages that a worker sees is minimized. Okay, and the condition that is given to us is that we are given the condition that okay, so we are given the condition that the workers will only look into consecutive cabinets. That is, if a worker looks into cabinet 1 and cabinet 3, this worker will also have to look into cabinet 2. It cannot be the fact that he looks into 1 and 3 and doesn't look into 2. So they should be all taking consecutive subarray of cabinets, right? So this is the question. We are given n workers, we are given m cabinets, we are given an array A. Now this array contains the number of pages there are number of files that are there in each cabinet, right? So the size of this will be m. What you have to determine is you have to minimize the maximum number of files. So what we have to do is we have to minimize. What we have to minimize? The maximum number of files a worker sees. So we have to minimize the maximum number of files a worker sees. There are m cabinets and each worker will see a continuous segment of cabinets. That is, let's say we have a cabinet structure like this. Let's take an example here. Let's say we have a cabinet structure like A1, A2, A3, or yeah, something like A4, A5. Let's say 5 cabinets, right? And these are the number of pages. So let's say we have 2 workers. So we can divide like this, that worker 1 will take A1, A2, A3, worker 2 will take A4, A5. Or we can divide like this, worker 1 will take A1, A2, A3, A4, worker 2 will just take A5. This is a valid division. But this division is not valid, that worker 1 is taking A1, A3, A5. Worker 2 is taking A2 and A4. This division is not valid. Each worker will take a consecutive subsegment or subarray of cabinets, right? So you have to, what we have to do, we have to minimize the maximum number of cabinets a worker has to see. So in these problems, so I'm telling that what my claim here is, this problem that I've defined, that can be reduced to this problem 0, 0, 0, 1, 1. We have to find the transition point, that is this point. We have to find the transition point. We can reduce, yes, when we have to find this transition point, right? So how can we reduce this to this, right? And in fact, this similar strategy will be, this exact same strategy will be used for every such problem, where you have to minimize some maximum amount or maximize some minimum, find the minimize the maximum value or maximize the minimum value or something like that, right? So whenever it is kind of like you have to minimize something, maximize something, maybe you can think about in this terms, right? So how can we do that? Just think about this, that let's say we have a predicate function. LLD question be asked for fresher for SD1 at Amazon. LLD question, not exactly LLD, like LLD is a vast topic, right? LLD is a vast topic. LLD comprises of object oriented programming, right? LLD comprises of design patterns. So questions can be asked only on this part, that you just have to determine class diagrams. You don't have to focus on design patterns, like whether you should use a factory pattern, whether you should use observe decorator pattern, or these things, right? You just have to like focus on the OPS part. Maybe like it might be given such question, like design something like parking lot, and you just have to create the classes that you want. So it might be asked, I'm not sure. Just look into some interview experience. Mostly it's not asked if you are like a fresher, but if you have some experience, in that cases it might be asked, right? Okay, so we have a predicate function. What is a predicate function? A predicate function is the Boolean function, right? A predicate function is a Boolean function. What does it take? What does it take? It takes, let's say we have X workers. It takes X workers, and it will tell whether we can, it will return true, like what it will return. Okay, it has X workers, and not X workers, sorry. It takes a workload, that is each worker will not see more than W pages, right? Each worker will not see more than W pages. W means each worker will not see more than W pages. So predicate of W is true if we can have a situation, or we can assign pages, rather cabinets, to the workers such that it will return true if we can assign cabinets to the workers such that none of them sees more than W pages. Otherwise it will return false, right? So if a P of W will return true if we can find a way, we can assign consecutive cabinets to workers such that no worker sees more than W pages, In that case, it will return true. Otherwise, it will return false. So just think about it. How does this vary? How does this P of W vary? When W increases, that means each worker sees more pages. Each worker sees more pages. The limit on which, the maximum limit to which a worker can see pages increases. Like let's say initially P of 2, that is a worker will not see more than 2 pages. Now it has been increased to 4, that means a worker will not see more than 4 pages. So each worker is starting to see more pages. So in that cases, the number of workers needed, what will happen to this? What will happen to number of workers needed? Can anyone tell what will happen to number of workers needed? When W increases, what happens to number of workers needed? Rather think of it like this, that if P of W is equals to X, P of greater than W will be what? P of greater than W will be what? Can anyone tell what will be the number of workers needed? What will happen to that? P of W is what again? It is if we can assign pages. Sorry, not P of W. Sorry, my bad. If W increases, why am I writing P of? P of W is true false only. If W, number of workers needed for W is X, then what happens when W increases? When W increases, what happens to the number of workers? Now each worker is starting to see more pages, right? So the number of workers needed is decreasing, because each worker sees more pages. Like initially they were seeing 2 pages, now they are seeing 4 pages. So the number of workers needed to complete all of them will decrease, right? What happens when W decreases? What happens when W decreases? The number of workers, just think about this. What happens when W decreases? Each worker sees lesser pages now. Like let's say initially they were seeing 4 pages, at least 4 pages. Now they are seeing they were seeing at max 4 pages. Now they are seeing at max 2 pages. So number of pages each worker sees is decreasing. So the number of workers will increase. So this means that, what does this mean? Number of workers, right? Number of workers is inversely proportional to the workload that number of pages each worker sees. So now, when is P of W true? When is P of W true? P of W is true when we can have an assignment, that is when for this W, if we can assign in such a way that the number of workers needed fits within our workload, right? So just think about it. Initially P of W is very less initially, right? So number of workers needed is much more than what we have. Like we have only 5 workers, but let's say we need 10 workers to have for each of them to see W pages at max. So we cannot give that much workload, right? So P of W will initially be false, and as W increases, this is W increasing, as W increases, at one point the number of workers is decreasing. At one point it will reach the value where we have that number of workers. So from then it will become true, right? So we are basically reducing the problem to the problem of 0 0, like just it falls to be 0 0 0 and 1 1 1 1, and this eventually becomes finding the transition point, right? We have to find the first occurrence of 1 or the first occurrence of true. That is the minimum number of pages a worker has to see, right? So that is there. So this is how we can reduce a lot of problems into 0 0 0 1 1 1 format, right? So it is very important for us to know how to find the transition point from such an array. So we are given the array 0 0 0 1 1 1 1. Let's how do we find the first occurrence of 1? And let's have another. Okay, here what we do is the approach that I generally follow is I will make sure my low always points to a 0, my high will always point to a 1. I will always make sure that my low always points to a 0, my high will always point to a 1. So if that's the case and we are running binary search, where should it ideally end? It should ideally end here, because low will point to this 0 and high will point to this one, and there will be no place for low and high to go anywhere else. So this algorithm will end at this point, right? The algorithm or the binary search will end at this point. So this point condition will be low less than high minus 1, right? So this condition will be low less than high minus 1, because low equals to high minus 1, it should break. Okay, so what do I do now? I will find the mid. At every step I will find the mid. So what is the mid now? There are 1 2 3 4 5 6 7 8 elements. 4 is the mid. 0 1 2 4. 4 is the mid. So this is the mid. Now I will compare if a of mid is 1 or 0. It is 1. If it is 1, what will I make? My high should always point to a 1, right? So I know the first occurrence of 1 will be before this. Before this can be the first occurrence of 1, or it will be before this. So I can safely move my high to this, because this is a 1. So I can safely move my high to this. So this will become the high. Next again mid. 0 1 2 3 4 5. 5 by 2 or 4 by 2, it will be 2 0 1 2. This will be the mid, right? So what do I do? What do we do again? We see the value is 0, right? So definitely our first occurrence of 1 is on the right hand side, but we have to make sure that the low points to a 0. So low point to the next element. The next element is 1, right? So this element is 0. Why not make low just point to this? Because low will always point to a 0. Why not make low just point to this instead of going one step further? So we can just make low point to this. Now what is the mid? This will be the mid. What is a of mid? It is 1. So we will make high point to the mid. So our high will be pointing to the mid. So it will come to this. Now see, this is where our loop will terminate, and we are eventually ending up at this point 0, 1, right? So we will have to return the value of high. This is how we'll do the binary search. So let's look into the code, and if you have any doubts, let me know. Any doubts that you have with the implementation, let me know. So let's write. Able to write anything. Or some. Okay, I code is some. Why it is not? If that's the case, then probably we have to whiteboard. Let me just. Anyways, let's actually write the code on the whiteboard itself. That I can't do right now. Let's write the code. So what we'll do, first int low equals to 0, high equals to n minus 1. We will first assume that low is pointing to a 0, high is pointing to a 1. Now if it's not the case, if a of low is equals to 0, if a of low equals to 0, then we probably, I'm not sure, sorry, if a of low should be 0 only. If a of low is equals to 1, I'm not sure what we should return, but we should return, I believe, 1 or 0. 0 is the transition point. I'm not sure what can be the case here. Else if a of high is equals to 0, right? If a of high is equals to 0, that means a of high equals to 0. This means that a of high equals to 0. This means that will return high should point to a 1, right? So there is only zeros. Like the last element is 0, that means there is only zeros, so we'll return minus 1. Otherwise, we'll do the binary search, like while low less than high minus 1, int mid equals to low plus high by 2. We will check if a of mid is equals to 1. In that case, high equals to mid, else low equals to mid. And we can return high. All right. So in low equals to 0, high equals to n minus 1. If a of low is equals to 1, in that case we'll return 0. If a of high equals to 0, in that case we only have zeros, so we'll return minus 1. While low less than high minus 1, int mid equals to low plus high by 2. If a of mid is equals to 1, then we'll return high equals to mid, else we'll return else we'll do low equals to mid, right? So our mid will always point, our high will always point to a 1, our low will always point to a 0, because we are always making it point to a 1 and low to a 0, right? And finally return high, because it will end at this point 0 comma 1. Low will point to this 0, high will point to this. This is where it will end, right? So this is the code. Unfortunately, I'm not able to write in the I'm not able to submit, but this is how the code would look like. I hope that there should not be any doubts, but let me know if there is any doubt with the implementation. Let's move to the next problem. We have spent a significant time on this. Okay, let's move to the next problem. The next problem that we'll solve is called the celebrity problem, right? Now this is a pretty interesting interview question, and it's also pretty popular, right? So it is said that a celebrity is a person who is known to all but does not know anyone at a party, right? So you are going to a party, or there is a information about a party. In that party, a person is a celebrity if he is known by everyone, but he knows no one, right? Who is known to all but does not know anyone at a party, he is a celebrity, right? If you go to a party of n people, a square n cross n matrix M is given to use to represent people at the party, such that if an element of row I and column j is set to 1, it means that ith person knows the jth person. So if m of ij is 1, then it tells that ith person knows the jth person. Here m of I will always be 0, because you cannot know yourself, right? You already know that. So you have to find the celebrity. That's the question. So for example, here n equals to 3 and we are given 0 1 0 0 0 0 0 1 0. So we see that all the people know 2, right? All the people know 2, but 2 does not know anyone. So 2 is the celebrity, or 1 is the celebrity if you consider zero based indexing, right? 1 is the celebrity. Second example is 0 1 1 0. If you see here, there is no celebrity, because the first person knows the second person knows the first person, so there is no celebrity between them. So this is the question. This is called the celebrity problem. You have to find celebrity, right? You have to find the celebrity. Expected time and space complexity is order of n and order of 1. Now how do we solve this? The first approach that will come to our mind whenever we see like we have a graph, like we have something like a person knows another person, and this is given in form of a matrix. We will always try thinking about a graph, right? So the first approach will be a graph based approach. And what is a celebrity? What is ideally a celebrity? A celebrity will be a person who will have n minus 1 incoming edges, right? It is a directed graph, a to b. The graph is directed from a to b. If a knows b, if a knows b, it is directed from a to b. It doesn't mean that it is also equals to b knows a. A knows b means only a knows b, doesn't mean b knows a, right? So a celebrity is a one who has n minus 1 incoming edges and 0 outgoing edges, right? It is a sink. So celebrity is a sink point. So we can compare the degree of every vertex or number of incoming elements for every vertex. So what will be the complexity for computing the number of incoming vertices? It will be order of n per vertex. So the total complexity will be order of n square, right? So that's definitely a solution where what you can do is you can find the degree of every vertex, the in degree and the out degree of every vertex. The in degree means number of incoming edges, right? So in degree should be equals to n minus 1, out degree should be equals to 0. Out degree should be equals to 0, right? So that's one. That's a n square complexity, right? Let's talk about the optimal way. So generally this problem, whenever this problem is presented, right? Whenever this problem is presented, it is not like you're given a matrix. Rather, it is said that you will have nothing but a Boolean function. Boolean function does no, which takes two arguments a and b. And it will return true. It will return true if a knows b. If a knows b and false otherwise. So you are not given access to the matrix as well. Whenever the question is asked in an interview, it is like you are given this method bool does know, which will take in two arguments a and b, and it will return true if a knows b. It will return false otherwise. So you will not have access to the matrix, although here we have, but generally we will not have access to the matrix as well. In those cases, how do we solve, right? So what do? We can definitely like go with the in order and out order logic, but that will be n squared. So let's talk about a better approach. So what we'll do is, let's say if the people are arranged as 1 2 up to n. So 1 2 3 4 like that up to n minus 1. So the people are arranged like this 1 2 3 4 up to n minus 1. Now we will keep two pointers, right? We'll keep two pointers, pointer 1 and pointer 2. Now what we'll call at every step, we will call at every step does no pointer 1 comma pointer 2. That means does 1 know n minus 1, does 1 know n minus 1. Now if 1 knows n minus 1, what does it mean? 1 cannot be a celebrity. 1 cannot be a celebrity, right? 1 knows n minus 1 means 1 cannot be a celebrity, because a celebrity cannot know any other person. That is the definition of celebrity, right? A celebrity, just see it. A celebrity is a person who is known to all but does not know anyone at a party, right? So if 1 knows n minus 1, 1 is definitely not a celebrity. In that case, what we'll do? We will do pointer 1 plus plus. So pointer 1 will move to 2. Let's say next we call does no pointer 2, and let's say n minus 2 is here. Does no 2 comma n minus 2. Let's say we call this. Now let's say it returned false. 2 does not know n minus 2. So 2 can be a celebrity. 2 does not know n minus 2. That means 2 can be a celebrity. But now we are ruling out the fact that 2 knows n minus 1, does not know n minus 1, means 2 can be a celebrity. but we are ruling out the fact that n minus 1 is a celebrity, right? Because n minus 1 is not known by 2. A celebrity should be known by everyone, right? So we will do ptr2 minus minus. So we'll come back to this position. Like this will continue. So if you look into this carefully, either does at any iteration. And how long will you continue? You will continue as long as while ptr1 less than ptr2. This is up to the range you will continue. Now this brings us to the conclusion that if you see, does no can only return true and false, and in both the cases we are either increasing ptr1 or we are decreasing ptr2. Thus we are reducing one element in our search space every iteration, right? So the total complexity, this will continue for order of n time, because every time one element is getting removed from the search space, so it will continue for order of n time. What is the space complexity? Only 2 pointers are needed, so it will be order of 1 space complexity. Now finally we will reach to the celebrity, but it is a candidate celebrity, right? Like it might happen that the celebrity knows someone. It is not actually a celebrity. For example, let's consider the case of 10, right? Let's use this algorithm for 10. Sorry, 0. What was the known 1001? This was the graph, right? Sorry, 0110. This was the first case, 0110. So we have 1 and 2. Pointer 1 is at 1, pointer 2 is at 2. We call does know 1 2. So 1 knows 2, right? So we'll do pointer 1 plus plus. So it goes here. Now we end the loop. Now is 2 a celebrity? 2 is not a celebrity, right? Because 2 knows 1 as well. So our celebrity cannot know. So for that we'll have to run an additional loop that will check whether the celebrity that we have chosen is a valid celebrity. That is, if is there anyone, like does he know any person? Does he know any person? If he doesn't know any person, he is a celebrity. Otherwise he is not a celebrity, right? So let's actually understand this with an example. Let's say we have 3 people, right? So let's consider that example 010 000 010. So we have 1 2 3. We'll start here. First of all, does 1 know 3? Does 1 know 3? No, right? So we will do ptr2 minus minus, because 3 is not a celebrity. Next, does 1 know 2? Yes, 1 knows 2. So we'll do ptr1 plus plus, because 1 is not a celebrity, because 1 knows 2. Now we end up here. So 2 is a candidate celebrity. Now we'll check for 2 whether this entire row is 0, or whether he knows anyone. The person 2 knows anyone. If he doesn't know anyone, then 2 is a celebrity. We'll return 2, otherwise we'll return minus 1. Right? So that will be the logic for this, and it will be order of n time, order of 1 space. I cannot write the solution because my keyboard is not working. Yes, it is not working. So we have to skip the solution, but I feel that you should be you guys should be good enough with the logic, and it's pretty simple to code. Like just you have to use a 2 pointer while ptr1 less than equal to less than ptr2. If does no ptr1 comma ptr2 is true, then ptr1 plus plus, else ptr2 plus minus minus, right? So that will be the code. Okay, so these are the 2 problems I wanted to discuss today. I hope that you like the problems, and these are a bit important with respect to interview. Okay. Next is, I think we have already done this problem before, but again, if we have not done this, you have to find the largest sub array with 0 sum, right? So you are given an array and you have to find the largest sub array with 0 sum, and the expected time and space complexity is order of n and order of n. So whenever there is sum, we'll use the prefix sum concept, and I've already, I think, discussed this before. This is one of the problems for your homework. Just try it again if already discussed. Second is square root of a number. So you are given an integer x, you have to find the square root of x, right? You have to find the square root of x, but the complexity should be, if you look into the complexity, it should be order of log n time, right? So you have to find the square root of a number in order of log n time. This is also pretty simple. If you can definitely like try to solve this. The third is rotate an array. So you are given an unsorted array n. You have to rotate the array left counterclockwise by d steps, where d is a positive integer, right? So you have to rotate the array by d steps. So this is also a pretty easy question. So these three questions are for your homework. I'm expecting that you will be completing all of them by Friday, and Friday we'll meet again with a new set of problems, right? So let me know if you have any doubts from today. Otherwise, we'll end the class here. Anyone has any doubts from today? Any question that was unclear or something, or any other doubts in general? You can let me know. Otherwise, we can end the class here today. All right. I don't think you have any doubts. Can end the class here. Thank you guys for joining, and we'll meet again on Friday.